Hello students, I am Marti Devrani, Assistant Professor, R.M.K College of Engineering and Technology. Previously we covered the parameters related to the open wire line. Now we are going to see the parameters related to the coaxial cable. Why we are going for to the open wire line and coaxial cable? In order to transmit the high frequency signal. High frequency signal is otherwise called as radio frequency signal. It is in the frequency range of megahertz and more. While transmitting the signal, there is a chance of skin effect. The skin effect means the signal will be transmitted on the outer conductor, not on the inside of the conductor. Then we are going to see some formulas related to the open coaxial cable. For a coaxial line, inductance is given by L is equal to 10 to the power of minus 7 into 2 ln of B by A plus 2 C to the power of 4 ln of C by B divided by C square minus B square the whole square minus C square by C square minus B square into Henry per meter. The second and third term represent the flux linkage inside the inner and outer conductor. The skin effect eliminates the flux linkages and hence the inductance of the coaxial line is given by L is equal to 2 into 10 to the power of minus 7 ln of B by A and L is equal to 4.6 into 10 to the power of minus 7 log 10 of B by A. The ln function is converted into logarithmic function. Here this is the formula. L is equal to 4.6 into 10 to the power of minus 7 log 10 of B by A. Then the capacitance of coaxial line is not affected by the frequency, but inductance will be affected by the frequency. C is equal to 2 pi epsilon by ln of B by A equal to 2 pi epsilon naught epsilon or ln of B by A is equal to C is equal to 55.5 epsilon or ln of B by A. How we get this value? By substituting epsilon naught is equal to 8.854 into 10 to the power of minus 12 in this equation. Then C is equal to 24.14 epsilon r by log 10 of B by A. The ln function is converted into the log function. Due to the skin effect, the resistance increase and the resistance of the coaxial line is R DC is equal to 4.16 into 10 to the power of minus a root of F 1 by A plus 1 by B plus 1 by A, where A and B are the outer radius of the inner conductor and inner radius of the outer conductor in meter. Therefore, the resistance of the coaxial cable is directly proportional to the square root of the frequency. The AC resistance of coaxial is derived as follows. Or DC is equal to or AC is equal to 1 by 2 pi A del sigma plus 1 by 2 pi B del of sigma equal to 1 by 2 pi del of sigma 1 by A plus 1 by B. The AC resistance per unit length of the copper conductor is given as R AC is equal to 1 by 2 pi 0.0664 by root of F into 5.75 into 10 to the power of 7 into 1 by A plus 1 by B. RDC is equal to 4.16 into 10 to the power of minus 8 root of F 1 by A plus 1 by B. The resistance is directly proportional to the square root of the frequency. So the resistance increases with increasing of frequency. The DC resistance of the coaxial line is given by RDC is equal to 1 by pi sigma into 1 by A square plus 1 by C square minus B square. The C represents the outer radius of outer conductor.